Hello friends, today's discussion is about the properties of square numbers. So to start with, perfect squares. So perfect squares are the square of a natural number like 1, 4, 9, 16, 25. These all are perfect squares as they are the squares of 1, 2, 3, 4 and 5 respectively. So let's see some square numbers. As you can see, it's a list of all the square numbers of the numbers starting from 1 up to 30. So when I say it's a square number, let's take a square number 121. So 121 is the square of 11. That is 11 square is equals to 121. So 11 into 11 is 121. In this way, we get the square numbers. So this list we have to by heart so that it will be easy for us to understand the properties. So let's start with the first property. It says a perfect square never ends in 2, 3, 7 or 8. So when I say it never ends, that means the units place is never 2, 3, 7 or 8. So as you can see the list, here we find that none of the square numbers end with 2, 3, 7 or 8. It is either 1, 4, 6, 9, 5 or 0 like this, but none of them end with 2, 3, 7 or 8. So we can say the numbers like this are, they can never be perfect squares. As you can see here, all of them end with 2, 3, 7 or 8 like this. So here you have to note one thing. The numbers that end with 0, 1, 4, 5, 6 or 9 may be or may not be a perfect square. That means if a number ends with 0, it is not compulsory that it should be a perfect square. Like the number 10. Now 10 ends with 0, but it's not a perfect square. The number like 34, it ends with 4, but it is not a perfect square. So this is not a reason to become a perfect square. But we can say that if it ends with 2, 3, 7, 8, it is never a perfect square. So this property identifies whether it is a perfect square or not. So moving on, property 2. So it says a perfect square never ends with odd number of zeros. So let's see a list here. Here we have taken some numbers like 10, 20, 100, 200, 1000 and 2000 and we have found the squares of it. So 10 square is 100 and 100 square is 10,000 like this. So here we notice that the number of zeros gets doubled. As you can see here, the number 10 has 1 0, but its square 100 has 2 zeros. Suppose if we take a number 200, it has 2 zeros, but its square 40,000 has 4 zeros. So the numbers just gets doubled. So here we can say that it can never be odd. As we are saying it is doubled, that means you are multiplying by 2. And if you multiply by 2, it can never be odd. It should be always even. So here we can say that if you are taking a perfect square, whatever it may be, it will never end with odd number of zeros. The number of zeros can never be odd. So here we say that the numbers like 20 and 12,000 like this, they can never be perfect squares as all of them ends with odd number of zeros. So here also you have to note one thing, that the numbers that end with even number of zeros may be or may not be a perfect square. So here I mean to say, suppose we take a number 100 and 200, both of them end with even number of zeros, but here we see that 100 is a perfect square, but 200 is not a perfect square. So this is not a condition to be a perfect square. So the odd number of zeros confirms that it is not a perfect square. But getting an even number of zeros doesn't make it confirm. It may be, it may not be. The third property, it says a perfect square when divided by 3 or 4 always leaves a remainder 0 or 1. That means when we divide a perfect square by 3 or by 4, either we'll get a remainder 0 or we'll get a remainder 1. So this says that suppose we'll take a number 81. Now 81 when is divided by 3 and 81 when is divided by 4. 81 is a square number. So we get the remainder as 0 and 1. So when we divide it by 3, we get 0, and when divided by 4, we get remainder is 1. So let's take another number, 64. Now when 64, we'll divide by 3 and by 4. Now when 64 is divided by 3, on division, the remainder will be 1. And 64 when divided by 4, the remainder will be 0. So we can check it by division. So here we can say that a perfect square when divided by 3 or 4 always will leave a remainder 0 or 1. So let's take here. Now if a number when divided by 3 or 4 leaves a remainder 2 or 3, that means if you divide it by 3 or 4, if the remainder we are getting as 2 or 3, then it can be never a perfect square. So here, suppose I take a number like 17. Now when 17 is divided by 3, the remainder is 2, and we know 17 is not a perfect square. Similarly, suppose we take 23 and divide it by 4, the remainder is 3, so it is not a perfect square. So here you have to remember, if a number when divided by 3 or 4 leaves a remainder 0 or 1, then it may be or may not be a perfect square. So the reverse is not true always. We say that perfect square when divided by 3 or 4 will leave a remainder 0 or 1. But if we take a number and divide it by 3, suppose we take a number 12 and divide it by 3 or 4, obviously we'll get the remainder as 0. But here we say that 12 is not a perfect square. Although on dividing by 3 and 4, we are getting a remainder 0, but it is not a perfect square. So here you have to be careful that the reverse is not true every time. Next, the property 4. Here it says that square of an even number are always even and square of odd numbers are always odd. That means if we take a square number like any even number like 12. Now if you find the square of 12, we get 144. So you can see here in the list also, any even number you take, like the number 4, its square is 16, both are even. Let's take a number 8, its square is 64, so both are even. That means square of even number will be always even, and square of an odd number. So here in the list we can take any odd number like 3, its square is 9, so it's an odd number. Similarly, square of 13, it will be 169. So here we say that even square will be always even, odd number square will be always an odd number. Next, property 5. This states that the units digit of the square of a number is the units digit of the square of the units place of the given number. So whatever the given number, its the units place if you square, the same thing will be the unit digit of the square number also. So let's consider this list. As you can see, suppose we take two numbers like 3 and 7. Now see here, the square of 3 is 9 and the square of 7 is 49. So both of them end with 9 only. So if we see that if the square number ends with 9, the given number will end with 3 or 7. So from this we get a list like this. So here you can see here, if the units digit of the given number is 0, its square will end with 0 only. And if we take the units digit of the number is 1 or 9, then its square will always end with 1. As you can see, square of 1 is 1, 9 is 81. So both of them are ending with 1. So using this list, so let's see here. Now we have taken some numbers, 2-digit numbers. So it will be easy to understand here. So here we can see, let us take the first one. Now consider this one, 21 and 29. Now on the table on the right hand side, you can see if the number ends with 1 or 9, the square will end with 1. So you can see here, 21 square is 441, 29 square is 841. So both of them are ending with 1. So here we can see here the given number is ending with 1 or 9, but the square number ends with 1. So by seeing the unit digit of the given number, we can say what will be the unit digit of the square number. And similarly, 22, 28, both of them here the square ends with 4. So the given number ends with 2 or 8. That means if it ends with 2 or 8, the square number will end with 4. Similarly, we can see here for 3 or 7. So 3 or 7, it ends with 9. For 4 or 6, it ends with 6. Both of them ends with 6 only. Similarly, 5 will end with 5 because 5 square is 25. So it ends with 5. So whatever the given number, if it ends with 5, its square will always end with 5 only. And the last one, if a number ends with 0, its square will also end with 0. Next, property 6. Now this says that if n is a perfect square, then 2n can never be a perfect square. 2n means the double of the number. So here we can take some numbers, perfect squares like 4, 9, 16, 100. Now here 4 is a perfect square. 4 is the square of 2. But if we double 4, the 4 2s are 8. But 8 is not a perfect square. Similarly, take 9. 9 is the square of 3. But 9 2s are 18. Now 18 is not a perfect square. So here we can say that if n is a perfect square, then double of it, that is 2n, will be never a perfect square. Or similarly, we can say 100. 100 is the square of 10. So 100's double is 200. Now 200 is not a perfect square. So you can see here the square numbers are 4, 9, 16, but its doubles, that is, if the square numbers are doubled, they will be non-square numbers. Next, property 7. Here it says that the square of a natural number n is equals to the sum of the first n odd natural number. So let's see here. So n squared, that is the square of a number n. So n squared is equals to sum of the first n odd natural numbers. So let's see here. Now here we have taken 1 squared. So 1 squared means sum of the first odd number. So first odd number is 1. Then 2 squared. As you can see here, 2n is 2 here. So 2 squared is equals to 1 plus 3. That is the sum of the first 2 odd numbers. The first 2 odd numbers are 1 and 3. So it is the sum of first 2 odd numbers. Now you know 1 plus 3 is how much? 4. So 2 squared is also 4. Then, so you can see here 3 squared. 3 means the sum of the first 3 numbers you can take. So 3 squared means 1 plus 3 plus 5. It gives 9. Similarly, 4 squared. 4 squared. So here n is 4. So the sum of first 4 odd numbers. So here 4 squared can be written as 1 plus 3 plus 5 plus 7. So here we can say that n squared equals to 1 plus 3 plus 5 up to 2n minus 1. So what is this 2n minus 1? 2n minus 1 is the last number of this pattern. The last number of this pattern. You can see here, when I take 4 squared, now 4 squared, the last number is 7 here. So 7. So how we get 7? Whatever the given number is 4. So we will double it. 2n. 2n means 8. 8 minus 1 will get 7. So here the same thing is written. So whatever is the given number, we will just double it and subtract 1. So we'll get the last number. So for example, take 9 squared. Now here n is equals to 9. That means 2n minus 1 will be how much? So 2n minus 1 is 2 into 9, 18. 18 minus 1 is 17. So now we know that the last number will be 17. And following the previous one, the sum of first odd numbers, odd natural numbers. So as we have taken n is equals to 9, we will add all the first 9 odd natural numbers. So let's see here. So 9 squared. So 9 squared starting from 1 up to 17. So it becomes easy to note how many numbers we are writing, whether we are going the correct way or not. So 9 squared is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, 15 and 17. So these are the first 9 odd natural numbers. Next, the difference of squares of two consecutive natural numbers. Difference of the squares of two consecutive natural numbers is equals to their sum. Now see here, that means if you take two consecutive natural numbers, one is n plus 1 n. That means it is like, suppose I take one of the number is 5, its consecutive will be 6. One of you will take 3, its consecutive will be 4. Now here n plus 1 is the greater one, n is the smaller one. So we are just finding the difference. So here it says that n plus 1 whole square minus n squared is equals to n plus 1 plus n. It is the sum of the numbers. So n plus 1 is a number, n is another number. These are consecutive, means serial numbers. So here we see here, it is like suppose I take 9. So if n plus 1 is 9, n will be 8. These are the consecutive. So we can see 9 square minus 8 square is equals to 9 plus 8. So let's check it whether it is correct or not. Now 9 square minus 8 square. Now 9 square is 81, 8 square is 64, 81 minus 64 is 17. Now the sum of the numbers. So we have taken the numbers 9 and 8. So when we add 9 and 8, we get 17. So this we can say that if the difference of the squares of the consecutive numbers is equals to the sum. So if we'll find the squares and subtract, it will be equals to the sum of the numbers. So the same thing can be written like this. So n plus 1 plus n on the right hand side can be written as like this. So 19 square minus 18 square. 19 is a number, 18 is the consecutive number. So here we can see just you have to find the sum. So 19 plus 18 we get 37. Similarly, 28 square minus 27 square. So we'll just add the numbers here. 28 plus 27 will get 55. That means if we'll find out the square of 28 and find the square of 27 and subtract, we will get 55. But it takes a lot of time. So this property is very much useful when we are finding the difference of the consecutive squares. Similarly, it can be a 3-digit number also. So 136 square minus 135 square, it's a large number. So instead of doing that, we can just add the two numbers and get the answer. Property 9. This says that between two consecutive perfect squares, that is n squared and n plus 1 squared. N and n plus 1 are consecutive, serial numbers like 1, 2, 2, 3 like this. So their perfect squares, that is n squared and n plus 1 squared. So in between them, there will be 2n non-perfect squares. So you can see here, suppose we'll take two squared numbers, consecutives, and in between them, there will be 2n non-perfect squares. So let's take an example, 4 square and 5 square. So this says that if you will find out the numbers in between 4 square and 5 square, there will be 2n non-perfect square. Now here n is 4. That means we will have 2 4s are 8. 8 non-perfect squares. Means these 8 numbers will be not square numbers. So let's say it. So 4 square is 16 and 5 square is 25. So in between them, we will find these numbers 17, 18, 19, 20, 21, 22, 23, 24. And we see that none of them are square numbers and it is equals to 8. So there are 8 non-square numbers. So in between these two consecutive square numbers, we have 8 non-perfect squares. So let's see some more. Like we can say it now. So in between 10 square and 11 square, we'll have 20 non-squared numbers. So as n is 10 here, just you have to multiply 2, double it. So 50 square. 50 square and 51 square. In between 50 square and 51 square, there are 100 non-square numbers. So how we get 100? Just multiply the first number 50 into 2. Similarly, in between 121 square and 122 square. Now n is 121 here. So in between that, 2 into 121, that is 242. So in between 121 square and 122 square, we have 242 non-squared numbers. So in this way, these properties will be very much helpful for doing the problems and identifying the perfect squares and non-perfect square numbers. Thank you and keep exploring.